Hello everybody. Today we're going to make this thing called the Beakman motor. It is a very simple DC kind of motor, and if you want to find more information, you can always do a Google search on the words Beakman and motor, and there you will find lots of sites that will give you instructions how to make them. So I'm going to go through a demonstration of making one here. The very first thing that we need to do is have an introduction. My name is Steve Goodman. I've got assistance from my daughter, Andrea Goodman, who's the camera person. If you have further questions and want to contact me, please feel free to email me at steven.goodman@mail.wvu.edu. I am a professor of electrical and computer engineering at WVU Tech. Before we actually build the Beakman motor, we need to understand something about the principle of its operation. And so this principle is used in every single electric motor there is. Now, other electric motors will have other principles involved, but nevertheless, every one of them will have this particular principle. So here, first I've got a rig that we have set up, and it includes a battery. This is a knife switch that can open and close. There's a wire, and then at the very end we have a magnet. The important thing about this magnet is that there is the whole surface here is one pole, and the other side is the other pole. It is also called a bar magnet, but it's not like one end is the North Pole and the other is the South Pole. No, it's the whole surface that is one pole. And so what we're going to do is we're going to put the magnet in close, but not touching the wire. And when I close the knife switch, that will cause a current to flow from the battery. It'll come around here in a counterclockwise direction, go through the switch, and then back to the battery. The important thing is that we would like to then see what's going on with the wire and the magnet. So I'm going to pull it in a little bit closer. We can take a look at right here. Again, the switch is open, and I'm going to close the switch. Now the problem is it's going to bounce a little bit, so you need to look at the initial direction of motion here. So I'm going to close the switch, and there we see that the wire has gone down. I've opened it again. Now it's very, very bouncy, so we'll smooth it out, and then we'll bounce it, close the switch, and see what happens. Okay, there it goes. I'm closing the switch, and you see that it's gone down quite a bit right there, so from its previous position. So I'll open up the switch, bounces a little bit, but now it's gone back to the position. Now, something very interesting here happens if I turn the magnet around, so that now we have the other pole of the magnet against the wire. Again, it's not touching, and so what we'll do is close the switch, and now we'll see the initial motion is having that wire go upwards. So we see that the wire's gone up. I'm going to release it, and then we come back down to its original position. So what we see also is if I turn it just kind of sideways like this, and then close the knife switch, nothing happens. Nothing happens. So there are some interesting aspects to this. Again, we have current that's flowing from the right to the left, and an arrow going this way. We have either one pole of the magnet, either North Pole or South Pole, and it makes a difference whether we have one pole or the other in terms of which direction this wire goes. But the main idea here is that the current through the magnetic field feels a force. And so here's the current going from side to side, the magnetic field is coming out, and then the force is either up or down. So we have really three dimensions there working with. And it does depend upon how close the magnet is. So if I close this and then bring in the magnet, we can see that as I pull it in closer, okay, then there is an effect. Keep it from bouncing so much. So here we have it. As I'm pulling it in closer, the wire goes up. Turn it around like so. We can see that here, bringing it in closer means that the current is feeling a stronger magnetic field. And so the amount of force is proportional to the strength of the magnetic field, which way it is pointing, and then how strong the current is. So these are some aspects that go into the main principle. And that principle is here, a current through a magnetic field feels a force. So that is the important thing that we need to have right in here. Current through a magnetic field feels the force. Now, in order to make this Beakman motor, we have a parts list here. And so here are the various parts that we'll have to have. And first we'll have a D-size battery. So this is one that I happen to use here, so we'll put that up. We need some paper clips. the whole thing of the Beakman motor was introduced to me by a nice lady named Judy at the public library who asked me if I could make a motor out of paper clips. Well, the answer is yes, but we need something more than just paper clips. But nevertheless, here they are, and so we'll need a couple, two of them, of these big jumbo size paper clips, and you can get an idea of how big they are. And so we'll put those aside here. We also need some electrical tape, and so just some of this black kind of stretchy tape, that's good enough for what we need. Good electrical tape. And then we need some wire. In this case right here, we happen to have some wire here. If we look very closely, it is right here, 20 gauge. That gives us the size of the wire, so it's not really big wire, it's not small wire, it's just the right size for what we want. In fact, instead of taking from that spool, I'll take it from this spool, and we see that this is wire that actually has a red coating to it. It's like insulation. This is sometimes thought of as transformer wire. This insulation is very important, so we can't get just bare wire. We need something that then insulates the wire up to a point. So, but nevertheless, there's the wire that we have. And then we need some of these magnets here. Now these are very strong magnets. Just to illustrate here, I don't have any glue in my hand, so I can try picking it up, but no glue. But if I put a magnet on top, lift it up, and here we see that the magnetic field is going through my hand and is able to pick up the magnet. So if I release, well, if I pull away one magnet, then the other one just simply falls away. So this is very important, very strong magnet that we have right here. So these are the parts that we need, really only 5 different parts, and so let's get into it and start building this. I'm going to move some of these out of the way here so that we have a nice clear surface. And so the first thing we're going to do is work with our battery and our paper clips. Now here then, with the paper clips, the important thing is that we want to open them up, and here, the way to open them up is we need to slide them apart here. So what we'll do is I'll take this and not pull it apart, but slide it apart. So here, as I'm sliding it apart, we see that it's still very flat, if you will, and I'll make it into a little bit of like an L shape. So here's the L shape, and we'll do that to both of these exactly the same way. And so let's pull this one out. So we've got 2 of those here. An example of one that perhaps is not done right here, if I just simply pull this apart, here I'm pulling it apart and we see that, okay, it's pulled apart, but it's not flat like it should, and so this is not going to work. This is not the way that we need to have it made. The next thing here is I'm going to pull off maybe an 8-inch section of this electrical tape, and so having a pair of scissors is sometimes fairly handy in terms of some tools that we'd like to work with. So here I'm going to take some scissors, and this is about roughly 8 inches or so. I'm going to snip it here, and then to make it a little bit easy, I'm going to put one end here like so that I've got one end of the tape on the battery itself, and now I'm going to take one of these paper clips. Now in this case, I'm going to take the end here that's the bigger end. Okay, this is the smaller end that is here. That's the small end, but I'm going to take the big end and I'm going to put it up against the cap of the battery, like so. All right, and then we have the tape that's already attached, and so I'm just going to wrap it around here, and in the process of wrapping it around, we get the paper clip making a nice, good contact with the terminal of the battery. Ultimately, these paper clips are going to help deliver the current to the motor part, to the part that rotates. They're also going to serve another function, and that is structurally they're going to support the part that moves. But we're not quite there yet. So these paper clips are very important, and so what we'll do is with the other end, we'll take the other paper clip, and exactly the same orientation as the first one, that they're kind of aligned that we see here. So you can see the alignment, and then taking the tape and again very carefully putting it on so that then we have everything nice and secure. So we have, and you can always make some adjustments if it doesn't come out quite right, and we'll make adjustments later on when we get the motor up and ready to turn. We might need to make a few adjustments, but the important thing is that they're nice and aligned, and that the ends here are connected to the battery, nice and solid. So here we can kind of almost think like a little cartoon character with legs and it can roll around. So we'll put this off to the side for the time being. Now, the next thing here, it's very handy to have a tube. This is a nice solid tube that came from a roll of paper towels. And then here is our electrical tape. And one of the things I'm going to anticipate here, once we have it, is I'm going to need a little bit of tape here. This is maybe, an inch, 3/4 of an inch, something of that sort. So here it is, and I'm just going to have that handy, and I'm going to set it to the side. And so here we'll just kind of stick it off to the side over here. We'll come back and pick that up in just a minute. It's handy to have that done in advance, otherwise I would need too many hands and fingers that I don't have. So what we'll do is that I'll take the wire, and here I'll have about, let's say maybe 3 inches from the end over to where I'm holding it onto the tube. And what we'll do is we'll just take this and wrap it around. So there's 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, and then I'll go another half turn like this here. So we have then about 7.5 turns, and the wire is thin enough just to cut fairly easily with some scissors. And so then here is our tube, and here are the loops or windings of the wire, like so. And so here's this. Then what we'll do is very carefully slide it off like this here. Now what we have is a nice kind of circular set of loops around here. We can make it a little bit more circular, and what I'm going to do is right where I see this piece coming out is I'm going to bend it straight out like this. And then that little piece of tape that we had just cut off at the very beginning, now I'm going to put it here and kind of wrap it together all around, and like so. That just kind of holds these loops together, otherwise they're going to spring out and go all over, and it's hard to deal with. So this holds them nice and compact. Now, one of the important parts here, this has to be done fairly carefully. This is the part that's going to end up rotating around. It's called the rotor, and we do need to use some care in making this. Now, one of the things is that I've got this piece here that's coming straight out. You can imagine right here in the middle of the circle, the center. And so if I think of this as being a line, it needs to go right straight through the center of the circle made by the loops of wire. And what we need to do on the other side is kind of an eyeball thing. We need to look to see where does this line come across, and then bend this just on the exact opposite side of that circle. So here's kind of the beginnings of this right here. Now I still need another piece of tape, so here it is. And if you wanted to, you could cut off both of these pieces of tape in advance. You only need 3 pieces of tape for the whole thing to begin with. So the long one around the battery, and then these 2 right here that hold the rotor together. And so here we wrap it around, and this is it. So that's it for the wire right here. And so here is our rotor, and a little bit of a test. I can kind of put it, well, I can sort of again eyeball it to make sure that we have these 2 ends that are sticking out nice and straight, and then again eyeballing it, looks like they kind of form a nice line. This may be sticking over a little bit like so, but here, and again this is a circle. Imagine this forming one continuous line, and it goes straight through the center. We can give it a little bit of a test right here. Just hold it between my 2 fingers, and I should be able to give it a little bit of a twirl and have it go around nice and easily. So that indicates here that we have something that's fairly well balanced. It's not perfectly balanced. If you need to, you can always take another little bit of tape and here put it put it here as an example, just to make sure that it's well balanced. So in this case right here, yeah, that might have been a little bit too much. So we can take this off, use the scissors. It might have gotten a little bit too much weight, but pull it off. It's okay here. So, and it was just about as good as it was to begin with. So we'll see. But you can play around with this, and we'll just go back to the way it was, and yeah, it should be in pretty good shape. Some cases you may need to play around with a little bit with the wires, but again, we need to make sure the wires are straight, and here that this can turn fairly smoothly and easily and doesn't take much and keeps on going. All right, that is the first part. Now here we can also do another little quick test. This is not going to turn because I don't have the magnet, first of all. There's another very important step we need to do, but this gives you the idea of how it's going to be. So here what we have is, I'm just holding the battery with the paper clips, and you can kind of see that the role of the paper clips is to support the part that rotates. The next part is very, very important, very crucial, and for this what we have is a fingernail file. I've also got an X-Acto knife that I can use as a nice scraper. So what we'll do with this part right here is, again with the fingernail file, and I'm going to support here, let's see, right here. So, and I'm going to then file away this red insulation. Now, as I mentioned, that the insulation we need to have, but in order to get electricity to go through the loop, we need to have a place where the electricity can get to the wire inside. The red part is an insulation and would keep the current from flowing. So what we need to do is we need to, with this fingernail file, remove some of the insulation. And so then I get most of that done with the fingernail file. And here with the X-Acto blade, I'm scraping off a little bit more. Now notice I am not going all the way around. Maybe we can zoom in a little bit on this part right here and just show you that here on this top part, you can see that it has the, right in here, the shiny copper color right there. But if I turned it around, I did not remove the insulation from all the way around, only on this top part right here. So if I'm holding it in my finger, I'm only erasing or removing the insulation like so. That's the only place that I need to have it. And then with this, I'm going to turn it around, and then here also on the same side as the other. So we see it down here, and so on the same side, I'm going to remove some more. Now, of course, your finger may be in the way a little bit right here, but that's okay. It doesn't really hurt, and the important thing is we get enough here, and then with this we can scrape it, being very, very careful. You may want to have an adult help you out with this if you need to, but here we see, again, some of that nice copper color shining through right here. Okay, so that gives us all the work that we need to do. So now what we can do is we can put this here. Now it's not going to work because I don't yet have the magnet. So, but the magnet's going to be put right up here. It's connecting to the battery, and I'm going to put the magnet right here in a position where the loop comes closest to it. So again, we want the current now going through the loop to come as close as possible to the battery. I might need to open this, pull this down a little bit like so, and sometimes I need to spread this out here, spread this out a little bit because the loop is fairly large. And so now here, making some of these adjustments, you might give it a little bit of a touch, and I feel just a little bit, so right there, we got it to go. Have to give this one a little bit of a head start, but we see that this is turning around, spinning nice and easily, so you can kind of see from different angles how it looks. I'm holding it so that this is at the lowest part here, and this part is here, this part of the paperclip, and this part right here of the paperclip is supporting the part that rotates. So here, this is an example of the Beakman motor. One of the things we could do is, again, take it off and modify this a little bit. Okay, just flatten this out, and you can play with it around a little bit some. Again, making sure that these wires here are straight. That's very important. And then if they get to be too long, we can always cut them off and make them a little bit shorter. I don't need all of the length at one side here. So sometimes a little bit of a push might be helpful just to get it going. And so here it is. There's the Beakman motor. Now, one of the things we could do with this is to think about how we might be able to improve on the design. We might be able to attach a little bit of a string, a very light string, a little bit of a lightweight, just to see how much we could lift from a motor like this. But nevertheless, here we have current that's flowing from the battery, here around through the paperclip, into the loop, and then back to the other paperclip, back to the battery itself. And then here with the magnet right there, then we've got current through the magnetic field, and it's feeling the force. So every time this thing loops around, every revolution, this wire feels a kick from the magnetic field and the current, and that's what keeps it spinning around and around. Now, when you're done, the best thing is to take it apart, just so that if you're going to set it down someplace, keep it like this, so that we don't inadvertently short out the ends of the battery. So if we were to leave the rotor inside here, there's a chance that the battery could be shorting out. It gets really hot, and we don't want that to happen. We want your battery to last as long as possible, and we don't want to cause any kind of fire hazards. So this is an example of the Beakman motor, and I think that you can have fun building it and have quite a bit of an enjoyable experience watching it work. But thank you for watching in, tuning in, and if you have questions, let me know. Thank you. Bye.